In the previous section, we described aspects of FPGA technology. By the end of this module, you will be able to add a FPGA VI to a LabVIEW project and view FPGA function palettes. Okay, let's talk about developing the FPGA VI. So remember, there is no operating system on the FPGA. When the FPGA VI is functioning or executing on the FPGA, it's actually being executed on hardware. When you're developing an FPGA VI, you can only download and run only one top-level VI on the FPGA at a time. Okay, so there's only going to be one top-level VI running on that FPGA. The FPGA can run independently of the host, so regardless of what the host is doing, the FPGA VI can be running on that FPGA separately and independently. The FPGA VI can also store data in memory using something called memory items and FIFOs, and we'll talk about that later in a separate lesson. When you create a FPGA VI under an FPGA target, what will happen is if you go to the functions palette, it'll populate with an FPGA palette that is specific for FPGAs. Also, when you're developing an FPGA VI, you'll usually use integer or fixed point math to perform calculations. Starting in LabVIEW 2012, single precision floating point is also supported. We'll talk about this a bit more in Lesson 7, Signal Processing. So to add a VI under an FPGA target, you'll want to go to your Project Explorer, and then you'll want to look at where the FPGA target is. So after you do that, you want to right-click the FPGA target item in your project, select New, and then select VI. So once you've created this FPGA VI, if you go to the block diagram and you try to view the functions palette, you'll notice that the functions palette will adapt to show functions that are compatible on FPGAs. So if you take a look at it, there are some palettes that are similar to LabVIEW for Windows. For example, there's still while loops. You'll still be able to do numeric and Boolean functions and things like that. But you'll also notice that there are some FPGA-specific palettes as well. So you'll notice that there's an FPGA IO palette that's specific to FPGAs, and also FPGA Math Analysis and things like that. One example is the FPGA IO palette. This is a palette on the functions palette that's specific to FPGAs. And in this palette, you'll find I/O nodes, which are the nodes that you would use to communicate with I/O through your FPGA. Another palette I want to let you know about is the FPGA Math Analysis palette. So on this palette, you'll find FPGA Math Analysis functions that are optimized to execute on an FPGA and also use a minimal amount of resources on the FPGA. The functions will typically perform point-by-point calculations. Okay, now let's dive into LabVIEW and take a look at these palettes. Okay, so now we've got a LabVIEW project open, and notice that this LabVIEW project has a CRIO in it, and it also has an FPGA target under the CRIO. Okay, so let's say we want to create a VI to execute on this FPGA. So what you want to do is you want to select the FPGA target, right-click it, go to New, and then select VI. So let me close this real quick. And now we have a VI, and you'll notice that over here on the bottom, you'll see that it is executing in the Compact Rio project, and it's also executing under the FPGA target. So let me go to the block diagram, and let me close out of this real quick. I just want to show you guys that this VI, notice that you'll see it right here, Untitled 1, and this VI actually is under the FPGA target. Okay, so now when I go to the block diagram and I go to the functions palette, so if I right click, notice that the functions palette is going to adapt to functions that are supported on the FPGA. Okay, so notice that some things in this palette are going to be similar to LabVIEW on Windows. So notice we have for loops, we have while loops, we have case structures. If you go to the numeric palette, you'll see that you have addition, subtraction, and things like that as well, and Boolean functions as well. Okay, I do want to point out that there are some other things, so let me pin this down real quick. So notice that here we have FPGA IO. If we go to this palette, notice that we have IO nodes, IO constants, and these are the things that you'll use to interact with your IO. So let's go back to our programming palette. Also, I want to bring your attention to data storage and transfer. So this is something that is specific to FPGA as well. So notice we have registers. We have memory. We also have FIFOs. Okay, So these are ways that we can store data and also transfer data on an FPGA, and we'll talk about this in a later lesson. Another one I wanted to point out real quick is also the FPGA Math Analysis palette. So let me click into here. And notice that over here there are some algorithms that are built into LabVIEW FPGA. So for example, if you need to do scaled windows or you want to do an FFT, these are things that have already been implemented in this palette. So instead of building your own, you can just use one of these. Notice that the FFT looks a little bit different on FPGA than it looks on a Windows system. So we'll talk about these functions a little more in the signal processing lesson, but I just wanted to show you for now. If you look into here, there's other functions as well. So if I go into the control sub palette, notice that there's already a PID function that's implemented for you as well. So if you need to do PID, you can use this function. All right, let's talk about top-level FPGA VI front panels. Okay, so as we know, with an FPGA, the hardware resources inside it are limited, right? An FPGA is going to have a finite amount of hardware resources. So one thing you need to do when you're programming for FPGA is you want to think about ways that you can try to use the minimum amount of resources that you need. So one way you can do that is you can use the minimum necessary controls and indicators for programmatic front panel communication to a host. So for every control and for every indicator that you put on your top-level FPGA front panel, there has to be some FPGA resources that are used in order to implement the logic of being able to communicate those controls and indicators back down to your host. Okay, so in light of this, you should try to minimize the amount of controls and indicators on your front panel and only use the ones that you need. Sometimes what you can do as a developer is you can add temporary controls and indicators for debugging, just so you can see what's going on inside your program. But when you're done using those temporary controls and indicators for debugging, make sure you remove them afterwards to save on your FPGA resources. Now you can add an FPGA VI to a LabVIEW project and view FPGA function palettes. Next, we will communicate between the FPGA and host PC using interactive front panel communication.